In this sequence, we're going to show you how you can implement your own templates, that is, sample solutions for specific process automation functions, in SIMATIC PCS 7 as a basis for carrying out the application engineering of your plant. In addition to these sample solutions which are created in the form of CFC charts, a sequential control program in the form of an SFC chart is also used. The SIMATIC PCS 7 library comes with standard templates, for example for motors, valves, and controllers. For the purposes of this exercise, we will make use of a customized library to show you how you can use your own company-specific templates. In the following steps, this library will be de-archived using the SIMATIC Manager. The individual CFC charts will be copied into the master data library. Copying is carried out between the library in the component view and the charts directory of the S7 program in the master data library. To de-archive the library, the menu command File De-archive must be carried out. In the De-archive Select Archive dialog, the archive file simlib.en zip is selected and opened. In the Select Target Directory dialog, the FAST-E folder is selected in which the project was stored. Since the charts contained in the library must be added to the project, we acknowledge with Yes to open the library. The three plans, Motor 1, Valve 1, and PID Control 1, are copied into the master data library. With the Control button pressed, the charts are selected one by one and copied into the Charts folder in the master data library. The charts are now available to be used throughout the project. The SimLib can now be closed. In the master data library, sample charts, functions blocks, measuring points, and higher-level engineered solutions are stored, so that they will be available for use in the entire project. The three CFC charts now have to be copied from the master data library FAST-E lib into the FAST-E PRJ project in the Function 1 folder of the system. Once the CFC plans have been copied, it is possible to carry out further configuration steps. The following tasks will be carried out in the Process Object view in the SIMATIC Manager. This view guarantees a uniform and comprehensive look into all important aspects of the complete automation solution. Many changes can be made here directly, without having to start the individual editing tools. Filter functions allow the number of displayed objects to be reduced in such a manner that only those objects are displayed that are required for the task at hand. In addition, an undo-redo function is also available. The three charts are displayed in the FAST-E lib library in the Templates folder. All three charts are now copied into the Function 1 folder. The charts are selected and copied into this folder using drag and drop with the left mouse button pressed. The charts are now available in the project. In our example, there are two identical process areas or units in the plant. Automation of both of the units must be carried out in such a manner that one unit is fully engineered first and tested prior to beginning configuration of the second unit. The automation programs of the first unit are then copied and adapted to the second unit. Before the CFC charts are interconnected, an SFC chart must be created to control the sequential operation of the motor and valve, since this configuration logic must also be available for the second plant section. The SFC plan SFC1, created by the PCS7 wizard in the Function 1 folder of the FAST-E PRJ project, is renamed and adapted for the simulation. In the first step, the SFC plan SFC1 that was created by the project wizard is renamed to Control. The object SFC1 in the Function 1 folder is selected with the right mouse button, and Object Properties is called up from the context menu of Operations. The engineering of the sequence of operations is carried out in the SFC editor. A step and its associated transition are now inserted. All of the required steps and transitions have now been entered. Before configuring the commands and transition criteria in the steps and transitions, the cursor must be set to selection mode. In the first transition, a condition must be entered which leads to a transition to the next step. The object properties of transition 2 are selected in the context menu. First, a comment is entered. The Condition tab is selected to enter the condition. The PV-in variable of the PID module in the PID Control 1 chart, which is to be used in the transition, is searched for by clicking on the Browse button. The transition must take place if this variable reaches a value greater than or equal to 50. The condition for this transition has now been inserted. The dialog can now be closed. Next, the commands for the subsequent step will be defined. The entries will again be made in the object properties. For clarity, the name is changed to Motor On. The minimal duration for execution of the step will be set to 10 seconds. It is entered in the Minimal Durations field. The Processing tab is selected to enter the commands which are to be executed during the step. The Auto On variable of the motor function block, which is contained in the Motor 1 chart, is located. The value that is to be written is true. This is done by entering the number 1. The motor is switched on if the process value PV-in goes above 50. After 10 seconds, the motor should be switched off again. The Motor On step and transition are copied. This is done by opening the context menu and selecting the Copy command. The sequence is pasted in the chart using the Insert command from the context menu. The object properties of the inserted Motor On sequence are selected. First, the name is changed to Motor Off. The Switch Off command is triggered. This is done by writing the value 0 instead of 1 to the Auto On variable of the motor module. The sequence of operations is now defined, and the SFC editor is closed. The sequence of operations called Control switches the motor 1, on as soon as the process value PV-in goes above 50. After 10 seconds, the motor is switched off again. This is a very simple application to illustrate the power and ease of use of the SFC editor. Real sequential control operations can be far more complex. For example, it is typically recommended to include an evaluation of the feedback signals within the transition conditions. The next step is to modify the default naming conventions that were automatically applied by the system, and to delete objects that were created by the system but that are not required in this example. The first step is to rename the Process Cell 1 folder to Process Cell. The Process Cell 1 folder is selected with the right mouse button, and Rename is called up from the context-sensitive menu. Now the Unit 1 folder is renamed Unit A. The CFC plan CFC1 that was created automatically by the project wizard is not needed, and thus can be deleted.